Hello everyone, welcome to part 3 of MONBUKAGAKUSHO Physics 2016 for undergraduates. And this particular question is relating to the particle dynamics. Now you see there are stacked blocks. Now read the question. A block P of mass m is on a smooth horizontal plane and an object Q of mass m is always on top of the block P. Initially, both P and Q are at rest. At the time t equals 0, an initial speed of v0 is given to P in the rightward direction. Then Q also starts to move. When the time t is passed after P is given an initial speed, the velocity of P coincides with the velocity of Q. The coefficient of kinetic friction here between P and Q is mu. And treat the rightward direction as positive and the acceleration of gravity is denoted as g, and we answer the following question. Now see, find the force acting on Q at time t, meaning that if it is at time t, we just find the time at the initial condition, right? So let's draw the free diagram. So there are block Q and block P. And the free diagram that we want to draw is mg, then there are normal and friction force. For P, there are friction force here, mg and n. Okay, now the first question, it is asked, find the force acting on Q at time t. So we focus on the object Q. So for the force, sigma F is actually 0. Why? Because Q, the block Q, hasn't moved, so there is no acceleration. The only force that happened is F, which is the formula is mu and normal force, which is mg. So the answer is A, right? The answer is A for number 1. For number 2, the question is find the force acting on P at time t. So at the block P now, we can see that this force, friction force, happens on P, but this weight force doesn't acting on block P, but it is acting on the ground, I should say, right? It acting on the ground. But for this Q, the weight is happen on the block P. So that's why for the force is also minus F, right? Because in the left direction. And the N is not capital mg, but it is little mg. So the answer is B. For number 3, find the velocity of P at time t. Okay, so in this particular question, it is asked on when the condition of P is already moving with v0. So the way to answer it, we know that v is v0 plus at, right? Because the velocity, the initial velocity is v0, it should be increasing or even decreasing over time. Let's look at the solution. So to find the value of that is sigma f is equals ma, but because the velocity happens at m, so we change it into big M, capital Ma, and we know that the force that happened is mu mg ma, so A is minus u m over m a, g, right? So we can substitute A to here, so V equals V0 minus mu m over m gt, and V equals V0 minus little m capital M mu gt. So this is the answer is D for this answer. So this is D. Okay, so for number 4, let's look at the next page. Find the expression of t using some other variable quantities. So for this particular question, it's somewhat hard, but it is still doable. So the value that we have got is v0 m over m mu gt. But this value can change, right? So that's why I made it v in t, little t. Now we are asked at t, capital T. Okay, so the way we actually do it is pretty much different with any other type of value that we have got before, right? Because the block P and block Q is moving together, right? So we have to calculate for block Q. All of this happen on block P. Now for block Q, VQ is also 0 plus AT. Now A, we can got it by the usual, this type. So sigma F equals MA, and mu MG equals MA, and A equals mu G. So VQ is mu G T. So because they are happening at the equal velocity, so the velocity of P equal velocity of Q. So V0 equals m over m mu gt plus mu gt. We can factorize it, m over m plus 1 mu gt. We can calculate this value. So m plus m over m mu gt. And we can calculate it further because we need to find t. So this goes up, this goes down, this goes down. So v0 over mu g, m over m plus m. So this is equal, this is little m plus m, v0 over mu g. So the answer is, where's the answer? It is this. Yep, it's G, right? M over m plus m times v0 over mu g. So the answer is G. Now for number 5, the question is, find the distance which Q move against P in the duration from t0 to t equals t. Now, at some point, when this block is moving, somehow when they are still attached together, so they move this way, when it gets even faster, the Q will be moved there. So that is the main problem for this question. Number 5. So object Q, A equals mu G, right? And that is for Q, and we know that D equals V0 minus 1 minus half AT squared. Okay, and then we can say that V0 is 0 for object Q, right? Because Q is only at rest when block P is moved. I'm sorry, this is plus, so D equals half AT squared. Now, from the fourth number, if we looked at the previous number before, we know that at this problem, that A is this, m over m plus 1 mu g, because we have found it before. So from 4, mu g, we can substitute this A with this value, so D equals half m over m plus 1 mu g, and we can do it as usual, m plus m over m mu g. And now what to do is, because there are t squared, oh I forgot there's t squared here, because it happens at time t, right? Now we already got t at question 4, right, which is this one, m over m plus m for v0 over mu g, and we can substitute that. So m plus m squared is m squared over m plus m squared v0 squared mu g squared. Just cross it out, and this cross, so it is equals to 1/2 then v0 squared over mu g equals to v0 squared over 2 mu g. So the answer is B. Yep. So that is, everyone, for part 2, for how to do the part 2 of the particular problem on the stack block. So the main way to actually to understand on how to do this particular question is to understand how stack block work. We need to actually understand on how to build such a free diagram. As I have stated before, that we focus on this, there are f and mg, and if you didn't understand my explanation, you can repeat it from the first. And yep, hope you understand my explanation for this part 3, and yep, stay tuned for another part, maybe part 4.